Welcome everyone. In this video I'm going to build my own microcontroller. As you can see, I have plenty of PCBs and now I also have a stencil, and this microcontroller will be a very nice ATmega32u4 board. I chose this square format, or designed in this way, because this was the most compact way that I could design this PCB. Of course, if you look up any kind of Arduinos, these Pro Micro or Pro Mini versions, they are more like elongated, like the Arduino Nano, for example. But this one has a square format, as you can see. And the rough dimensions is like 3.5 centimeters on both edges. So it's relatively small, and it's relatively compact, and hopefully it will work. This is my first design for this microcontroller. I try to look for a lot of tricks and tips regarding the design and how all the components should be put together. So hopefully I haven't messed up anything and haven't messed it up anywhere. So we will see after that. And as I mentioned, and as you can see, this time I have a stencil, because I have never tried applying the paste with a stencil. And since I have a lot of components really close to each other with the relatively small solder tabs, I decided to go with the stencil and try it. So I will try the stencil, and you will see if I fail or not. This will be my first try. And as you could have guessed, based on the items that I placed here and based on the product that I'm showing, the video is sponsored by PCBWay, who made these gorgeous purple colored PCBs. I again chose another color from them because I want to test their wall palette. If you remember, I have a blue color, the PCB from them already, and then I also have, for example, a red one. And then I also tried other colors like black, white, and the regular green color. But now we have a purple one. And I will show you some close-up pictures if you go to my website. Link is in the description, and you will see how gorgeous this board is. So PCBWay is a service provider specialized on PCB manufacturing, PCB assembly, but they also have other services such as CNC machining and 3D printing, both in plastic and metal. So if you want to have a similarly nice PCB, or even better than you have a quite easy way with PCBWay. You just click on the PCB instant quote, and once you reach this website, you go to Quick Order PCB, and you have this option, Add Gerber File. So here you upload your Gerber file, and then further down here you can customize the board. And I think the most important parameter here is the number of boards, how many PCBs you want to receive. And if you go further down here, you can customize the color. If you have noticed, I chose this very nice purple color, but I can also recommend you the white one because it's very nice, I think. And if you go further down, I want to highlight this part here. If you don't want to struggle with applying solder pin by pin or tab by tab, you can order a stencil. And I have ordered a stencil for my current build, and I can recommend it because it makes my work much more easier. But if you also want to have easier work, you don't need stencil. You can go directly to their assembly service, and they will take care of everything. So they will order the parts for you, and they will assemble the board for you, so you will receive a ready-made board. So I hope you like PCBWay's products and services, and you will consider using them. And now all we have to do is that I have to align this stencil over one of these boards perfectly, and then I will apply some solder paste. And I have some solder paste already. I bought it recently, and hopefully this will work properly. And then I have my miniature soldering station with 3 by 3 centimeters area, but actually it will be enough for the parts. So we will use this soldering station or hot plate just to solder everything. So let me prepare this area, and then we will see if I fail or not. So if you have been following my channel for a while, you should know that I have designed some larger PCBs, and they will come handy. I haven't built all of them, and these are the PCBs from the first version of my coil winder PCB. And I will use them because they have the same thickness as this purple PCB. And they will be perfect for supporting the stencil over the parts which I'm trying to solder. So then I will align this, hopefully in a proper manner. Then I apply some tape, which I can already apply. And then that will hold the stencil over the required area in a correct manner. So this is just a visual alignment, and I will just try to see if everything is aligned, and it seems like that it's nearly perfect. So and just to be on the safe side, I apply the tape here as well. And now this seems perfect. So what I'm going to do is I apply this solder paste and see how it behaves. So as I can see it with naked eyes, the solder paste was applied perfectly. So now I have to be very careful and apply the parts. And now I will switch to the microscope camera because I will put this under the microscope. So you will actually see a bit more about this. So this is the completed circuit board, as you can see, and now it's basically ready to be tested. So all I have to do, I have to find a USB cable, which I can kind of sacrifice and disassemble, so I can provide 5 volts through this USB port here. So I just butcher one of my cables, and then we will see if this thing emits smoke or it is a microcontroller. So now you can see the cable goes in, and then I have the 5 volt power supply here, and it goes to my laboratory power supply, which is now set to 5 volts, and I will decrease the current to 100 milliamps. And I just turn this thing on, and we will see if we reach 100 milliamps or not, and we will also see if one of the LEDs goes on or not. So let's see. 0.017 amps, 17 milliamps, which is kind of the range of this thing. So far so good, and I cannot see the current raising. And if I turn on the lights, you might see this very dim green LED there. So the power is at least there. And the other two LEDs are for the serial communication, so it's okay to not see them right now. So that's so far so good, and it's promising. So now what I have to do is actually, this suggests that it is safe to plug it into my computer. So let's go to my computer and let's see how this looks like when I plug it in. Alright, so I assembled the circuit, and you can see the 3D model of this circuit, which is made in KiCad. You can see that a few components, for example the resettable fuse or the USB port or the crystal, is missing, but this is basically the same board that I made. And now I have to connect it to the computer via USB. So let's do it and let's see what happens. So now I'm connecting it, and you could probably hear the device sound. So there was this typical sound from Windows 10, and we could see that the device was connected. And now comes the issue. So we go to the device manager and see what happens. So here is the device manager, and here is our small board, ATmega32u4 DFU. And the problem is the following, which I have to show you through the Arduino IDE. So let's go to the Arduino IDE and let's see what's the problem with this. So here is the IDE with an empty sketch, and now we are trying to connect to this device. So we go to Tools, and of course I have already selected this ATmega32u4 because I recently installed the library for this kind of breakout. But this is the big problem. There is no port here, and it says nothing because I cannot select the board. And also if I try to open the serial monitor, then at the bottom of the screen, which I bring up here, you can see that board at COM25 or whatever it is, it's not available, but I cannot even see the board at COM25. So something is really fishy here. But we should not be so much disappointed because there is a workaround for this. So the thing is that there is another way to program this board, and that is that we can do this programming via ICSP. So essentially we can use another Arduino device. We can upload a program to that one, which turns that device into an ICSP programmer, and then we use that Arduino as a programmer, and that Arduino will be connected to this board via basically SPI, which are also the ICSP connection. And with that we can upload the program to the device that I just built, and we can run it. And how that is done is that we have another Arduino, and then we have already uploaded the code to it, which turns it into a programmer. And then we go to Tools, and we still select this board as ATmega32u4 breakout, but the programmer has to be set into Arduino as ISP. So this will let the Arduino IDE know that we have selected the programmer as an other external device, which is an Arduino. And with that, we have to connect everything. And once everything is done, this port is available, because that will be the port which is the programmer's COM port. So I should do that, and I should show you how it's done. So give me a few seconds because I have to wire these things up. So now I have connected the Arduino Uno, which is set up to become an ICSP programmer. So I go to Tools, and now you can see that the port became available here. So I just select COM6. And now I connect it to my Arduino Uno, which is the programmer. And basically that's all. We set up the Arduino as ISP. Everything is nice. So let's create some very simple code here. And what I want to do is that let's create the serial. So serial.begin and 9600, so the typical baud rate. And we also define a variable here, which is a long, and let's call it counter, starts from 0. And what we do here is that serial.print line, and we print the value of the counter, and we increase the counter after printing it, and we put a delay of, let's say, half a second here. So what this does, we initialize the serial in the setup, and then in the loop we go on, and every half a second, 500 milliseconds, we print the value of the counter. So 0, and then 500 milliseconds later, this becomes 1, and then another 500 milliseconds, 2, and so on and so on. So this is so far fine. So COM port is selected, Arduino as ISP is selected. So now I have to go to Tools and burn bootloader here. And now I can see that this is done. So it went on, and now we are done with this part. So I can remove the Arduino. You should hear the sound soon. And now I add my other board via USB. I just need to arrange the cables. And now the device is setting up some kind of AVR CRC bootloader, which is done, and it says that the USB serial device at COM26 is ready. So we select the COM26 and we try to open this, and as you can see, nothing happens here. So now since the COM26 is open, I select USB ASP here, and then I press upload, and now again there was a connection disconnection series, and the device is ready to go. And there we go. Here is our counter running nicely. So the board is working, as you can see, and every half a second we get a new number, and then it goes on and on. So as you can see, I have successfully built this device, and it seems like I haven't destroyed it, luckily. So the soldering was fine, and everything went well. I also confirmed that the USB or the serial connection is working, since we received the data from the microcontroller. And I also confirmed that the SPI is working, because the SPI was the selected port for programming this externally. So that also worked. And that's all. So of course I will have to test this board a bit more, because I have to test the I/O pins, I have to test the I2C pins. But as a first trial, I would say that this is a very successful test. I'm very happy with the results. So now what I'm going to do is I'm going to test this board, of course, in my free time, not on this video, because it's already getting too long. And then after testing, I can have this kind of layout as a layout for other boards where I need a microcontroller with USB connection and so on and so on. So this board can be extended to other devices. So yeah, this was the whole video. I wanted to show you this gorgeous board. I think this purple color is very nice as well. Yeah, it really shows the traces very nicely. The contrast between the board's color and the traces color are just perfect. So yeah, it's very spectacular. So thank you PCBWay for this very nice board. Thank you for providing it for me. And if you want to see this device in a better resolution or in better angles, I took a few extra photos of this device. So head to my website, link is in the description, and you can see a bit more better pictures than the video, I believe, because the lights and everything were a bit more better when I took the pictures. And also you will find this board available via PCBWay.com. So if you go to my website and check the link on my website, which I published, you can go directly to PCBWay and buy this board from them. So you don't have to struggle with the board design and so on. And as you can see, you can have a quite nice board. So I hope that this video was useful to you. I hope you learned something, and see you in the next video.